Hey there, get comfortable. Let your body settle into wherever you're resting right now. Tonight, I want to take you somewhere extraordinary, somewhere most humans will never go, somewhere so deep, so mysterious, that we know more about the surface of the moon than we do about this place. We're going to the Mariana Trench. Now don't worry, you don't have to do anything. You don't have to remember any of this. Just listen. Let my voice carry you down, slowly, gently, through layers of blue that grow darker and more peaceful the deeper we go. The Mariana Trench sits in the western Pacific Ocean, about 200 kilometers east of a chain of small volcanic islands called the Mariana Islands. It's shaped like a crescent moon lying on its side, stretching for about 2,500 kilometers. That's longer than the Grand Canyon is 5 times over. And at its deepest point, a place called the Challenger Deep, the trench plunges nearly 11 kilometers beneath the ocean's surface. If you could somehow pick up Mount Everest and drop it into the Challenger Deep, the peak would still be more than 2 kilometers underwater. Let that sink in for a moment. 11 kilometers of water, 7 miles, 36,000 feet of ocean pressing down, layer upon layer, blue fading to black. But here's the beautiful thing. We're not going to rush. We're going to drift. We're going to take our time, passing through each layer of the ocean like turning pages in a very old, very patient book. Before we slip beneath the waves, let me tell you how this place came to be. Because the Mariana Trench isn't just deep water, it's a wound in the earth itself, carved by forces so slow and so powerful that they make mountains look like ripples. You've probably heard of tectonic plates, these massive slabs of rock that make up the Earth's crust. They float on a layer of hot, slow-moving rock beneath them, drifting just a few centimeters each year, about as fast as your fingernails grow. Out in the western Pacific, 2 of these plates meet, the Pacific Plate, which is enormous and ancient, and the smaller Mariana Plate. And here's where it gets interesting. Where these 2 plates meet, they don't just bump against each other. One slides beneath the other. Scientists call this subduction. The Pacific Plate, being older and denser, sinks down beneath the Mariana Plate, diving into the Earth's hot mantle below. And as it sinks, it pulls the ocean floor down with it, creating this immense trench. This process has been happening for tens of millions of years. Slowly, steadily. The same way water carves a canyon, except this is rock sliding beneath rock, inch by inch, century by century. And as the Pacific Plate descends, water trapped in its rocks gets squeezed out. That water rises, melting the rock above it, creating the volcanoes that form the Mariana Islands. So the same process that made the deepest place on Earth also built the islands that sit beside it. I find that beautiful. Creation and depth, born from the same ancient motion. For most of human history, nobody knew the Mariana Trench existed. The ocean was deep, everyone knew that. But how deep? No one could say. Then, in December of 1872, a British ship called the HMS Challenger set sail on a journey that would change everything we knew about the sea. This wasn't an ordinary voyage. The Royal Navy had stripped out most of the ship's guns and filled the space with laboratories, specimen jars, and measuring equipment. For 3.5 years, the Challenger sailed the world's oceans. Its crew lowered weighted ropes into the water over and over again, measuring how far they sank before hitting bottom. They collected samples of water, mud, and strange creatures from depths no human had ever reached. Then, on March 23, 1875, the Challenger stopped in the Pacific Ocean, southwest of the Mariana Islands. The sailors began lowering their sounding rope, expecting it to hit bottom like it always did. But the rope kept falling, and falling, and falling. After nearly 27,000 feet, about 5 miles, it finally touched bottom. The crew had just discovered the deepest known point in all the world's oceans. They named it the Challenger Deep, after their ship, and that name has stayed ever since. Of course, their measurement wasn't quite right. They were using rope and weights after all. Later expeditions with better technology would find that the Challenger Deep was even deeper than they thought, nearly 36,000 feet at its lowest point. But those sailors on the Challenger were the first humans to know that such impossible depths existed, to understand that beneath the waves lay a world more vast and more mysterious than anyone had imagined. Alright, let's go in. Take a breath. Close your eyes if they aren't already. Imagine you're slipping beneath the surface of a warm, tropical ocean. The water closes over you like a blanket, muffling the sounds of the world above. This first layer of the ocean is called the epipelagic zone, but most people just call it the sunlight zone. It stretches from the surface down to about 200 meters, roughly 650 feet. This is the ocean most people know, the ocean of postcards and snorkeling trips. Sunlight floods down from above, warming the water, feeding the tiny plants called phytoplankton that drift through every drop. Did you know those microscopic plants produce about 70% of the oxygen in our atmosphere? More than all the forests on land combined. With every breath you take, you're breathing air that came from these sunlit waters. The sunlight zone is crowded with life. Tuna slice through the water like silver arrows. Sea turtles paddle slowly, ancient and patient. Dolphins arc through shafts of light. Jellyfish pulse like living lanterns, but we're just passing through. Watch how the blue above you begins to deepen, how the light softens, how the colors start to shift from bright turquoise to something richer, quieter. The temperature is already dropping. At the surface, the water was maybe 25 degrees Celsius, pleasantly warm. But as we sink, we enter what scientists call the thermocline, a layer where the temperature falls rapidly. Don't worry, you're safe. Just notice how the world is changing around you. Getting cooler, getting quieter, getting deeper. We've crossed into the mesopelagic zone now, the twilight zone. This layer stretches from about 200 meters down to 1,000 meters, roughly 3,300 feet. And it's called the twilight zone because this is where sunlight fades away. Look up. Can you still see the surface? Barely. Just a faint blue glow, like the sky at dusk. The sun's rays are being absorbed, scattered, swallowed by the water above us. Soon they'll disappear entirely. The creatures down here have had to adapt. Many of them have enormous eyes, huge, round, dark eyes, designed to capture every last photon of light. Others have given up on seeing altogether and navigate by sensing vibrations in the water. And then there are the ones who make their own light. In the twilight zone, you'll start to see something magical. Little sparks of cold blue light drifting through the darkness. Flashes and glimmers, living stars. This is bioluminescence, the ability to produce light through chemistry. And down here, it's everywhere. Scientists estimate that more than 3/4 of all animals in the deep sea can produce their own light. They do it for all sorts of reasons. To attract mates, to lure prey, to confuse predators, to communicate in a world without sunlight. Watch that jellyfish drift by, pulsing with soft light. See how it glows when something brushes against it? That's a defense mechanism. The flash startles predators, giving the jellyfish time to escape. And there, that hatchetfish with the flat silvery body. See the row of lights along its belly? Those match the dim light filtering down from above. To a predator looking up from below, the fish becomes invisible, its silhouette erased by its own glow. Scientists call this counter-illumination, camouflage made of light. The temperature has dropped to maybe 10 degrees Celsius now. Cold, but not freezing. The pressure has increased too, about 100 times what you feel at the surface. But we're adapted for this journey. We keep sinking. As we drift deeper, you might notice something floating around us. Tiny white flecks, drifting downward like snowflakes in slow motion. This is marine snow. It's not actually snow, of course. It's organic matter. Dead plankton, bits of decaying creatures, waste, mucus, all the tiny remnants of life in the waters above. It clumps together into soft, fluffy particles and begins the long journey down. Some of these flakes will fall for weeks before reaching the ocean floor. Week after week of slow, silent descent through miles of dark water. Marine snow is the deep ocean's food supply. Without sunlight, nothing can photosynthesize down here. No plants grow, so everything depends on this gentle rain of organic matter from the world above. Creatures wait in the darkness, filtering these particles from the water, scraping them from the mud. The whole deep-sea ecosystem, every fish, every worm, every microbe at the bottom of the Mariana Trench, depends on this snow that never stops falling. I find that beautiful, that the sunlit surface, where whales breach and seabirds dive, is connected to the deepest, darkest places on Earth by this constant, quiet gift. Life feeding life, mile after mile after mile down. Watch the flakes drift past you. Let them settle your mind. Everything up there is still happening. The sun is still shining, fish are still swimming, waves are still breaking on distant shores. But down here, there's only the snow and the darkness and the slow descent. 1,000 meters. We've entered the bathy pelagic zone, the midnight zone. And now, for the first time, there's no light at all. Look up, nothing. The surface is 3,000 feet above us now, and not a single photon of sunlight reaches this deep. We are in complete, permanent darkness. This zone stretches from 1,000 meters down to about 4,000 meters, roughly 13,000 feet, and it is vast. This layer alone makes up about 75% of the entire ocean by volume. Most of our planet is midnight zone. The temperature has dropped to about 4 degrees Celsius now, just above freezing. It will stay close to this temperature all the way to the bottom. The deep ocean doesn't change seasons. It doesn't feel the warmth of summer or the chill of winter. It's simply cold, everywhere, always. The pressure is crushing now. At 3,000 meters, it's roughly 300 times the atmospheric pressure at the surface. Imagine 300 atmospheres pressing against every square inch of your body. But the creatures here don't mind. They've evolved for this. Their cells are built differently. Their bodies are soft, flexible, designed to function under pressures that would destroy anything from the surface. And there's still life here. That's the miracle. Even in complete darkness, under crushing pressure, in near freezing water, life finds a way. Speaking of light in the darkness, let me tell you about one of the most remarkable creatures down here. You've probably heard of the anglerfish, maybe seen pictures of it. That bizarre fish with enormous jaws and a glowing lure dangling from its forehead. The females are the ones with the lures. That little glowing ball, called an esca, hangs from a modified spine that extends from the top of their head like a fishing rod. And inside that esca live billions of bacteria that produce light. The fish can control this light, making it pulse and flicker to attract curious prey. In a world of absolute darkness, any light is mesmerizing. Small fish swim toward the glow, drawn by curiosity or confusion, and then the anglerfish strikes. Food is scarce in the deep. The anglerfish might wait weeks between meals. So when prey comes close, those enormous jaws can swallow fish, almost as large as the anglerfish itself. But here's the really strange part. The males. Male anglerfish are tiny, sometimes just a few centimeters long compared to the foot-long females. They don't have lures. They don't hunt. They have enormous nostrils designed for one purpose: finding a female. When a male finds a female in this vast, dark ocean, an almost impossibly rare event, he bites onto her body and never lets go. Over time, his body fuses with hers. His organs dissolve. He becomes nothing more than a small attachment on her body, providing what she needs to reproduce. It sounds harsh, but think about it from evolution's perspective. In a world where finding a mate is nearly impossible, ensuring you never lose one is worth any price. The deep sea requires strange solutions, and somehow that makes it beautiful. 4,000 meters. We've crossed into the abyssal zone. The word abyss comes from an ancient Greek word meaning bottomless. For centuries, people believed the ocean had no floor, that it simply went down forever into darkness. We know better now, but I understand why they thought that. At this depth, with nothing but darkness in every direction, it feels like you could fall forever. The abyssal zone stretches from 4,000 to 6,000 meters, roughly 13,000 to 20,000 feet. The pressure here is 400 to 600 times what you feel at sea level. 8 tons of pressure on every square inch. And yet, life persists. Not as much life as in the waters above. Food is scarce this deep. But there are creatures here. Strange, soft, beautiful creatures that have made peace with the darkness. Sea cucumbers crawl across the muddy seafloor, vacuum cleaning the sediment for any organic particles they can find. Some of them look like fat little sausages. Others have elaborate tentacles or strange transparent bodies. There's a type called the sea pig. Picture a small, pink, puffy creature with stubby legs, trundling across the ocean floor like a tiny underwater piglet. They're actually quite common down here. Sometimes they gather in groups of hundreds, all facing the same direction, following the faint currents that bring food. The abyssal plains that cover much of the deep ocean floor are among the flattest places on Earth. More than half of our planet's surface is covered by these plains, vast expanses of soft mud, undulating gently in the darkness. Imagine standing in the middle of a desert that stretches to every horizon. Now imagine that desert is 4 miles underwater, in permanent darkness, near freezing, and pressing against you with the weight of 400 atmospheres. That's the abyss. Now we're approaching the edge of something extraordinary. 6,000 meters. The beginning of the hadal zone. The name comes from Hades, the Greek god of the underworld. And it's fitting. We are now deeper than almost anywhere else in the ocean. Deeper than the abyssal plains, deeper than the trenches that scar other parts of the ocean floor. The hadal zone exists only in the deep trenches. Those V-shaped gashes in the Earth's crust where tectonic plates collide and one slides beneath another. There are about 46 hadal zones in all the world's oceans, but they make up less than 1/4% of the entire seafloor. Tiny, rare, almost impossibly remote, and the Mariana Trench contains the deepest hadal zone of all. The pressure here is staggering. At 7,000 meters, it's roughly 700 atmospheres, over 10,000 pounds per square inch. At the bottom of the Challenger Deep, it reaches more than 1,000 atmospheres. If you brought a styrofoam cup down here, it would crush into a pellet the size of a thimble. The pressure would squeeze out every pocket of air, compressing the foam into a solid mass. Life refuses to surrender. At about 7,000 meters, we start to see the snailfish. They don't look like much at first. Small, pale, translucent, about the size of your hand. Their bodies are soft and gelatinous, with tiny eyes and a tadpole-like shape. But these little fish hold a remarkable title. They are the deepest living fish ever discovered. Scientists have filmed them at depths of more than 8,000 meters, over 26,000 feet down. Their bodies are perfectly adapted for this crushing environment. They have no swim bladder, that air-filled sac that helps most fish control their buoyancy. Air pockets would be catastrophic down here, crushed instantly by the pressure. Instead, the snailfish's body is full of a chemical called TMAO, trimethylamine oxide. This chemical stabilizes their proteins, keeping them functional even under pressures that would destroy the proteins of any surface fish. Their bones are barely calcified, more cartilage than bone, soft enough to flex under pressure rather than shatter. Their skin is so transparent you can see right through to their liver. And despite all this, they're thriving. Down in the hadal zone, snailfish are apex predators. They gobble up amphipods, small shrimp-like creatures, by the hundreds. In a world where food is scarce, they've found their niche. Watch one swim past now. See how slowly it moves. It's conserving energy. Everything down here moves slowly. There's no rush in the deep. Below the snailfish, below where any fish can survive, the amphipods rule. Amphipods are small crustaceans, relatives of shrimp and crabs. Most of them are tiny, just a few centimeters long at most. But in the hadal zone, something strange happens. They get big. Scientists call it gigantism. Some hadal amphipods grow to more than 30 centimeters, about a foot long. One species, Alicella gigantea, can reach 13 inches. That's enormous for an amphipod. Nobody knows exactly why they grow so large down here. It might be the cold water, which slows their metabolism and lets them live longer. It might be the lack of predators. It might be some quirk of the food supply. What we do know is that amphipods are everywhere in the trenches. Drop bait to the bottom of the Mariana Trench, and within hours, sometimes minutes, swarms of amphipods appear, scrambling over each other to reach the food. They're scavengers mostly. Any organic matter that falls from above, a dead fish, a whale carcass, marine snow, they're there to consume it. They're the cleanup crew of the deep recycling nutrients, breaking down the dead to feed the living. Recent research has discovered something remarkable about hadal amphipods. The extreme pressure dissolves calcium carbonate, the mineral most crustaceans use to build their shells. So the deepest amphipods have found a different solution. They absorb aluminum from the seafloor sediments and incorporate it into their shells. They're literally armored in metal, protecting their calcium carbonate from the corrosive pressure. Evolution finds a way, always. Let me tell you about the humans who came this way before us. In January of 1960, just 9 years before humans walked on the moon, 2 men climbed into a cramped steel sphere and sank to the bottom of the world. Their names were Jacques Piccard and Don Walsh. Piccard was a Swiss oceanographer whose father, Auguste, had designed their vessel, a strange craft called a bathyscaphe. Walsh was a lieutenant in the United States Navy. Their bathyscaphe was called the Trieste. Picture an enormous tank filled with gasoline, not for fuel but for buoyancy, since gasoline is lighter than water, with a tiny steel sphere attached to the bottom. Inside the sphere, just barely large enough for 2 men, was where Piccard and Walsh would make their journey. On January 23, 1960, they began their descent into the Challenger Deep. The trip down took nearly 5 hours. 5 hours of sinking through darkness, watching the pressure gauges climb, feeling the cold seep through the steel walls. At 32,000 feet, they heard a loud crack. Something had broken. For a moment, they must have wondered if this was the end, if the sphere would collapse, crushing them in an instant. But it was only an outer window in the access tunnel. The pressure hull was intact. They decided to continue. At 1:06 p.m. local time, they touched bottom. Their depth gauge read 35,814 feet, nearly 7 miles down, the deepest any human had ever gone. They spent 20 minutes on the floor of the Challenger Deep. Outside their tiny window, they saw what Piccard described as a waste of snuff-colored ooze. The seafloor, disturbed by their landing, had kicked up clouds of sediment that obscured the view, but through the murk, they thought they saw something. A flatfish, about a foot long, swimming slowly across the bottom. Life, at the deepest point on Earth. Later, scientists would debate whether it was really a fish. It might have been a sea cucumber. But it didn't matter. The point was made. Even here, at pressures of over 1,000 atmospheres, in complete darkness, in near freezing water, life existed. Piccard and Walsh rose back to the surface. The ascent took over 3 hours. When they emerged, they had achieved something that would stand as a record for over 50 years. Don Walsh lived to be 92. He passed away in July of 2023, having seen the ocean exploration he pioneered continue and expand. Jacques Piccard died in 2008 at 86. We're approaching the bottom now. 8,000 meters, 9,000, 10,000. The walls of the trench narrow around us. We're in a slot canyon now, a deep, V-shaped valley carved into the ocean floor. The Challenger Deep isn't a single point but a small basin, about 10 kilometers long and less than 2 kilometers wide. 10,900 meters, nearly 36,000 feet. The bottom. We're here. The pressure outside is over 1,000 atmospheres, more than 15,000 pounds per square inch. If we weren't protected, the weight of all this water would crush us instantly, compressing us into something unrecognizable. But here we are, safe, watching. The bottom is covered in that soft, pale sediment that Piccard described. Diatomaceous ooze, scientists call it, the accumulated remains of countless tiny organisms, drifting down over millions of years. Think about that. Millions of years of marine snow, slowly building up, layer upon layer. Every inch of this seafloor took centuries to form. And if we wait, if we watch very carefully, we might see life. There, a pale amphipod crawling across the sediment. And there, something that might be a small worm burrowing into the mud. Single-celled organisms called foraminifera, building their tiny shells from whatever minerals they can find. Even here, even at the very bottom, life persists. Let's stay here for a moment. There's nowhere deeper to go. We've reached the end of the descent, the lowest place on the surface of our planet. Above us, 11 kilometers of water, 7 miles, 36,000 feet. And then, beyond that, the surface, waves and sunlight and air, ships crossing the Pacific, seabirds riding the wind, and farther still, land and cities and all the noise of human life. But none of that reaches here. Here, there's only stillness, only silence, only the slow fall of marine snow and the patient crawling of creatures who have never seen light. I want you to feel that stillness. Let it settle over you like a blanket. There's nothing you need to do, nothing you need to think about. Just rest here at the bottom of the world, where time moves differently and everything is quiet. Since Piccard and Walsh made their historic dive in 1960, only a handful of other humans have touched this bottom. In 2012, filmmaker James Cameron descended alone in a submersible called the Deep Sea Challenger. He spent several hours exploring, filming, collecting samples. He described the Challenger Deep as a desolate, lunar-like landscape. In 2019, explorer Victor Vescovo made multiple dives in a submersible called the Limiting Factor. He reached the deepest recorded depth of any human, 10,928 meters, and he returned to do it again and again. In 2020, the Chinese submersible Fendouje, which means striver, carried researchers to the bottom, collecting samples and mapping the terrain. In 2020, Catherine Sullivan became the first woman to reach the Challenger Deep. She was also, incidentally, the first American woman to walk in space. Think about that. Having touched both the highest vacuum and the deepest ocean, all of them came here. All of them saw what we're seeing now. This soft, pale floor, this crushing silence, this improbable life. More people have walked on the moon than have visited the bottom of the Mariana Trench. You might think it's silent down here, and in a way it is. There's no wind, no waves, no human noise. But the deep ocean has its own sounds. In 2015, scientists lowered a special hydrophone, an underwater microphone, into the Challenger Deep. It was the first time anyone had recorded sound at such depths, and they heard things: the low rumble of distant earthquakes, the deep moaning songs of baleen whales traveling thousands of miles through the water, the crack and boom of typhoons on the surface, translated into pressure waves that reached even to the bottom, and unfortunately the sound of ships, propellers churning, engines thrumming, human noise penetrating even to the deepest places on Earth. The ocean is not as quiet as we thought. Sound travels differently in water, faster, farther. A whale song can cross entire ocean basins. An earthquake in Japan can be heard at the bottom of a trench near Guam. Let me tell you something that makes me sad, but that you should know. When Victor Vescovo reached the bottom of the Challenger Deep, he saw something unexpected. Not just the pale sediment and the strange creatures. He saw a plastic bag and candy wrappers. Human garbage at the deepest point on Earth. Scientists have found microplastics in the tissues of amphipods from the hadal zone. Chemicals from industrial pollution in the bodies of creatures that have never seen sunlight. Our fingerprints are everywhere, even in places we've barely visited. It's a reminder, I think, that even the deepest, most remote places on Earth are connected to the surface, that the choices we make up there ripple down through all those miles of water, settling like marine snow on the bottom of the world. But here's the thing, the ocean is resilient. Life down here has survived for millions of years, through ice ages and mass extinctions, through shifting continents and rising and falling seas. If we give it a chance, it will survive us too. And in the meantime, we can come here, even if only in imagination, and witness its beauty, its strangeness, its patient, quiet persistence. We've been here a while now, at the bottom, in the stillness. But it's time to start rising, not quickly. There's no rush, just a gentle lifting, the way you might rise from a deep sleep, slowly becoming aware of the world again. As we rise, think about what we've seen. The snailfish with their translucent bodies, the amphipods in their aluminum armor, the marine snow falling forever, the bioluminescent creatures, making their own light in a world without sun. Think about the explorers who came before us. Piccard and Walsh, crammed into their tiny sphere, trusting their lives to a craft that had never been tested at such depths. Cameron descending alone into the darkness. Vescovo returning again and again, mapping the contours of the deep. They went because they wanted to know, because the unknown called to them, because even when the world above is full of noise and chaos, there's something in us that yearns for silence, for stillness, for the quiet depths. We're passing through the hadal zone now, 9,000 meters, 8,000. The pressure is easing, just slightly. The walls of the trench are widening. In the distance, a snailfish watches us go, then turns and swims away into the darkness. 7,000 meters, 6,000. We're leaving the hadal zone behind, entering the abyss again. Those vast, flat plains that cover so much of the ocean floor. The creatures here are a little more familiar. Sea cucumbers on the mud, brittle stars with their delicate waving arms. Occasional fish, pale and slow, drifting through the darkness. 5,000 meters, 4,000. The abyssal plains fall away beneath us. We're in the Bath Ipelagic zone now, the midnight zone. Still completely dark, still cold, but not as crushing. The bioluminescence seems more frequent here. Little sparks of light in the darkness, a jellyfish pulsing, something flashing in the distance, too far away to identify. 3,000 meters, 2,000. We're entering the twilight zone, the mesopelagic, and for the first time in hours, there's a change above us. Not light, exactly, not yet, but an absence of total darkness. The faintest suggestion that somewhere, very far above, the sun exists. The creatures here have larger eyes. They're trying to capture every photon, every hint of light from above. Counter-illuminated fish with their bellies glowing. Translucent jellies, things that look like they're made of glass. 1,000 meters, 900, 800. The blue is returning, that deep, rich blue that means light is filtering down. We're rising toward the day. 500 meters. Light, real light, filtering down through the water. The blue is brighter now, warmer. We're back in the epipelagic zone, the sunlight zone, the ocean that most people know. And suddenly, there's so much life. Schools of fish flashing silver in the light, jellyfish drifting, a sea turtle paddling slowly toward the surface. The water's warmer here, the pressure is gentle, the colors are returning, blues and greens, the silver of fish scales, the purple of a passing jellyfish. 200 meters, 100. You can see the surface now, that shimmering ceiling of light above us. Waves moving, distorting the sunlight into dancing patterns. 50 meters, 20. And then, we're back. The sun is warm on the water. A breeze ripples the surface. Somewhere in the distance, a seabird calls. But beneath us, far, far beneath us, the deep remains. The trench is still there, cutting into the earth's crust. The creatures are still there, crawling and swimming and glowing in the darkness. They don't need our attention. They don't need our approval. They've been there for millions of years, and they'll be there long after we're gone. But now you know they're there. Now you've seen them in your mind's eye. You've drifted down through all those layers of blue and black, and you've rested at the bottom of the world. You can close your eyes now if you haven't already. Let the journey settle into your body. Let your muscles relax one by one, your shoulders, your arms, your hands. Your chest rises and falls, slowly like waves on a calm ocean. Your legs are heavy, sinking into whatever you're resting on. Your feet are still. Imagine the darkness of the deep. Not frightening, comforting. A darkness without demands, without expectations. A darkness where nothing needs to happen, and everything can simply be. Imagine the marine snow falling gently through miles of water. Soft, white flakes drifting down, down, down. Let your thoughts be like marine snow, light, slow, settling. Imagine the pressure of the deep, not crushing, but holding, like being wrapped in the heaviest, warmest blanket you've ever felt. Safe, supported, still. The creatures of the deep don't worry about tomorrow. They don't regret yesterday. They simply exist, moment to moment, in the darkness they've always known. You can exist like that too, just for tonight, just for now. No past, no future. just the gentle darkness and the slow fall of snow and the quiet patience of the deep. The Mariana Trench has been there for millions of years. It will be there tomorrow and next week and next century. The snailfish will still be swimming. The amphipods will still be scavenging. The marine snow will still be falling. And you can return there whenever you want, in your dreams, in your imagination. Whenever the world above feels too loud, too bright, too fast, you can sink down through the blue, past the twilight, past the midnight, into the deepest silence there is. Rest now. You've traveled farther than most humans ever will. Sleep well, dream of the deep. Good night.